Go.
So the problem says that the function f is continuous at x equals 1. If f of x equals the square root of x plus 3 minus the square root of 3x plus 1 over x minus 1 for x cannot equal 1, and k for x equals 1, then k has to be, and these are our answer choices.
The definition of continuity states that the limit as x approaches c of fx equals f of c. So in this case, we can write limit as x approaches 1 of fx is equal to f of 1 equals k.
So for the function, if we try direct substitution and plug in a 1, you're going to get 0 over 0, which is an indeterminate form. And then the next step is to factor, but in this case, since you can't factor, you can move on to rationalization. So if you rationalize, you have x plus 3 minus the square root of 3x plus 1 over x minus 1, and you multiply both top and bottom by the square root of x plus 3 plus the square root of 3x plus 1, and the bottom the same thing.
And the quantity of cosine of x plus h minus cosine of x all over h. And here,
When you FOIL the top, you'll get square root of x plus 3 squared minus square root of 3x plus 1 squared over x minus 1 times square root of x plus 3 plus square root of 3x plus 1.
So now that you have this, you know that squaring a square root means that the square root will cancel out, and you'll be left with x plus 3 minus 3x minus 1, since you distribute the minus sign to both 3x and 1. The denominator will stay the same, and now you can simplify even further. Negative 3x plus x gives you negative 2x, 3 minus 1 gives you a positive 2, and the denominator stays the same. Now you can simplify even more. You can take out a negative 2 and you'll be left with x minus 1. And once again, the denominator will stay the same. Now we have a common term on both the numerator and the denominator, and you can cancel them out. And now you're left with negative 2 over x plus 3 plus the square root of 3x plus 1. As our definition of continuity stated that the limit as x approaches 1 of f of x equals f of 1, which equals k, we can now plug in what we got here into our function. So the limit as x approaches 1 is negative 2 over x plus 3 plus the square root of 3x plus 1, which is equal to f of 1, which in this case will be negative 2, 1 plus 3 plus 3 times 1 plus 1, which, if you simplify, you will get negative 2, 1 plus 3 is 4, and the square root of 4 is 2, as well as over here, 3 times 1 is 3, plus 1 is 4, and the square root of 4 is 2, so 2 plus 2, which is equal to negative 2 over 4, which is equal to negative 1/2 if you simplify it further.
Since the limit as x approaches 1 of fx equals f of 1 equals k, negative 1/2 is k. So here's our answer, and thanks for watching.